Let's continue our discussion about types of growth by going back to the question at the beginning of this section. Which retirement plan do you choose? So remember the options. Option 1, when you retire, your employer will pay you $2,500 for each year you are employed. So that's going to be a constant amount of growth. Option 2, when you start your job, your employer will deposit $2,000 into your retirement account, and then your account will earn 12% annual interest for each year you're employed. That is, your balance will increase by 12% each year you're employed. So here we have a percent growth. All right, for option 1, is the growth in your balance linear, exponential, or neither? And same thing for option 2. Pause the video and answer those questions and restart the video when you have it. All right, so for option 1, we see that we have a constant growth of $2,500 for each year. That's literally the rate of change, or the slope. $2,500 per year. So when we have that constant rate of change, we have linear growth. And so I'll let you explain it. All right, you write it out here. But it should say something about constant rate of change, or adding the same amount each year, something like that. All right, so for option 2, what we see is we've got a percent increase, increasing by the same percent each year. And when we have that, we have exponential growth. And we saw that on our last activity when we did this, this problem right here. Right, this exponential growth right here. We saw this kind of a shape when we were increasing by 15%. So for this one, you go ahead and explain, but you should say something about increasing by a fixed percentage. And again, all that is summed up on the previous page, which I would encourage you to read. So here we have this growth by a fixed percentage. We're going to get this kind of a shape in our graph. All right, well, let's complete the table and see how much we would have in our retirement accounts if we chose either of these options. So please pause the video and fill out the table. I'm going to fill out the table too, so when you stop pausing, when you unpause the video, it's all going to be filled out. So make sure you do it on your own first before you start the video again. Alrighty, take a look at the table. How did you do? Hopefully you got it. I'll write out a couple things here. Again, I think we do pretty well when we're just, adding to 2,500, adding 2,500, adding 2,500, adding 2,500. Some students struggle a little bit when we skip now and we're going up to year 20. So we need to think about the fact we're doing repeated addition. We're starting really with $0 in our account, and then we're adding $2,500 for each year, in this case 20 years. All right, for 40, we're starting with $0 and we're adding $2,500 over 40 years. And that's how you get the 50,000 and the 100,000. When we come over here to repeated multiplication by a percent, we're increasing by 12%. So our multiplier is 1.12, which we get from 100% plus 12% is 112%, and then the decimal representation of that is 1.12. So we're doing repeated multiplication by 1.12, and then we have to skip to 20. Right, we're skipping to 20 years here, so we have to think a little bit smarter about how to get there instead of just keep multiplying by 1.12. So we have to think, well, I'm starting with $2,000, and then I'm going to multiply that $2,000 by 1.12 for every year. So I'm going to end up multiplying that 20 times, multiplying by 1.12 20 times. For 40 years, I'm starting with $2,000, and I'm going to multiply by 1.12 40 times. in order to get this $186,101.94. Question number 4, for each option, write equations relating your balance B and the number of years T since you were hired, then graph those equations on Desmos. All right, so let's do that. Again, these are very similar to the problems that we did in the last activity. And writing out how you're getting your answer, writing out something like this can be very helpful in thinking about the equation. So since we just did option 2, let's look at that one. So we see that however many years since we were hired, that's our exponent there. So the balance in our account for option 2, we're going to start with $2,000, and then we're going to multiply by 1.12 for each year that we are hired. So that's going to be our exponent. It might help to actually even put that in our table and put a T here and see that, okay, well, if this was T years, I'd have to basically write this equation again, just like, or this expression right above it, but I'd have to the T power, right? And that would be your formula for figuring out the balance in your account after T years. In option 1, we started with $0 in our account, and then we added $2,500 for each year. And since it's repeated addition, that means we're going to multiply by T. Now 0 plus 2,500 times T is just 2,500 times T. So those are our two equations. Let's go over to Desmos and take a look at what that looks like. I've got my scale set here from activity 1. I'm going to hit this home button and just take it back there, although I'm going to have to change my scale in a minute to reflect the growth in the money, which are pretty big numbers. So option 1, our balance is $2,500 times T. Let's get this worked out. So let's pull this out this way and pull this down. Oops, there we go. We got a ways to go here. Remember, you can also use the this tool over here, this wrench. That's kind of a quick way to do it too. I just like this guy. Okay, there we go. Now let's put in our balance for option 2, which is, we started with $2,000 and we're multiplying by 1.1, what was it, 1.12? 1.12 to the power of T. All right, so if we look at this graph, now I can't really see where they're crossing up here, so I'm going to pull that down and see what's happening. So remember, the Y value here represents the money. So in this situation here, the black line is higher or showing me more money than the red curve. So we could see that in our table as well. That was option 1. If we look at these years, option 1 has got more money. So after 3 years, option 1 was $7,500 and option 2 was only about $2,800. Even after 20 years, option 1 was a lot more money, $50,000 versus a little more than $19,000. But when we skip to 40 years, we see all of a sudden out of the blue, option 2 just skyrockets up to $186,000. I guess it's not out of the blue. It wasn't a whole nother 20 years, but you know, it's almost double what option 1 is. And that's really what you see when you look at a graph of exponential growth. It's growing, but then it starts to grow faster and faster and faster. We could actually see where these two options have the same output. Right here is called a break-even point, where the two graphs cross, which is at the point 32.7. So after about 33 years of working, the two options would have the equivalent amount of money in the retirement account, about $82,000. So if you plan on working for this company more than 33 years, you should choose option 2, this red graph right here. Even though you're getting less money here, eventually, if you're going to stay there for that long, then go with option 2. If you're planning to work for this company less than this amount of time, 33 years, you probably are going to want to choose option 1. Now, there might be one exception to that, which is happening right down in here. I mean, if you were only going to work 1 year, it really doesn't make that much difference. I'm going to assume they're not going to pay you for a half a year. So even if you were only going to work 1 year, option 1 would be better here. Option 2 is only better if we're going to have quite the career with this company. 33 years, that's quite a long time, isn't it? So there is one more question here, which is, which retirement plan would you choose? Explain why you made this choice. So I will leave that to you based on the graphs and the tables that we've seen.